Hey everyone, I'm William Key from the School of Engineering.
Hi everyone, I'm Nathan Zhang from the School of Arts and Sciences.
Today, for the PURM project, we'll be talking about the physics of the violin bow, and more specifically, the Salchow test. So, how different vibrational qualities of violin bows are related to their physical properties is still pretty poorly understood, which is why um, for the summer, we researched the Salchow test, which is a test that violin players can perform to assess the quality of a violin bow. And it involves holding the bow at the frog in your bow hand and tapping the bow hair on the other hand and observing how long one feels a vibration in the bow. And we built a mechanical jig of the Salchow test to observe what the vibrational patterns look like, how patterns vary with the force applied, how patterns vary with the location of the tap, and if different bows differ in their fundamental frequencies during the Salchow test.
So we had three hypotheses going into this test. The first one of which was that all violin bows should exhibit a fundamental frequency around 50 hertz during the Salchow test. This means that when you tap it on the spectrum, there should be always a peak at 50 hertz for vibration in the X, Y, and Z direction. Our second hypothesis was that an increased force applied to the tap should also increase the power of the vibration in all directions, X, Y, and Z. And thirdly, a quote unquote better quality bow, which we measured just by price, should exhibit a longer vibrational decay. And our three bows were a cheap carbon fiber bow, a cheap fiberglass bow, and a pretty expensive wooden bow.
If you're interested in what the jig that we built looked like, it's on the bottom left-hand side of the poster, and you can see we built it out of aluminum extrusions, and it basically just performs Salchow tests by standardizing a certain force by dropping it from a different height.